This is log review part 2 for unit 4. All right, so remember when thinking about logs, it's very important to be able to go between the two forms, go between exponential and logarithmic forms. So again, just to recap, if we think about that, we think for exponential functions, we have base to some exponent equals an answer. And for the log, you have log base answer equals exponent. That just helps to keep, and that always just helps me to remember how the logs and exponents are related. So then to really be able to, we're getting towards solving more problems using some more complicated both logarithmic and exponential problems. So let's talk about the properties of logs. So the three properties, actually maybe I'll also do the change of base here. So properties of logs. First one is multiplication within a log can be split out as addition in separate logs. I'm just going to write these down, but then we're just going to work with it. And the second one is that division within a log can be separated out into subtraction. And third one is if whatever's inside the log, it has to be everything that's inside the log, is raised to some exponent, then that exponent can come out in front. And let's also right now talk about the change of base. Well, it's often important, or a very useful tool, I should say, to be able to rewrite a log in terms of any base you want. So say you had log base b of x. Well, I can rewrite that. Say I wanted to rewrite that in terms of a common log or base 10. That would be log x over log b. Say I wanted to write it in terms of natural log. Natural log of x over natural log of b. Say I was really interested in writing in terms of base 2. Log base 2 of x, log base 2 of b. So important to remember the change of base. And we did proofs of these in class, so I'm not going to do them here. But let's jump into practicing this. So say I wanted to, say I had a problem like this. So write only in terms of log A, log B, and log C. So breaking up a log. So say I had log base 2 of let's do a cubed square root of b over c squared. Okay, so this is the same as log base 2 of a cubed root b minus log base 2 of c squared. So remember, division goes to subtraction, but then I have multiplication within here. So this is the same as log base 2 of a cubed plus log base 2 square root of b minus, well, I'm going to bring the exponent in front here, 2 log base 2 of c. And last that I have to deal with is just the exponents. So the 3 comes in front. And remember, any root can be written as an exponent. It's the denominator of an exponent. So this would just be plus a half log base 2 of b. So that's splitting up a log. What if we wanted to go the other way? What if I said write as a single log? And we had something like this. Let's stick with log base 2 just to make it easy. All right, what if I had 3 log base 2 of x minus minus, let's say, 1/2 log base 2 of y minus 7 log base 2 of z. Okay, well, to write as a single log, kind of the rule, what I always think of is, anything that has subtraction up front goes in the denominator. And the reason that works here, and people sometimes get confused by that, is say with these two, if I factor out a negative, then I have 1/2 log base 2 of y plus 7 log base 2 of z. So it means that if I'm relating these two to each other, so actually let's look at these two first. These two can be related once I deal with the number in front and write it as an exponent. Those two can be related to each other via multiplication. So actually let's work with what's beyond the minus sign. So I have minus log base 2 of y to the 1/2, or the square root of y, plus log base 2 of z to the 7th. And then again, this will go to, addition will go to multiplication. So log base 2 of x cubed, I just brought that 3 up as an exponent, minus log base 2 of root y z to the 7th. And then subtraction again goes to division. So x cubed divided by square root of y z to the 7th. Now, honestly, I don't do that. I actually don't do that many steps. I know if I go back to the beginning here, I know that the numbers in front can go up as exponents. And then I know that anything with a negative in front is going to go in a denominator when we put it into the single log. But I just wanted to show you all these steps to convince you that was the case. Anything with a positive in front is going to be in the numerator. All right, so that was just using the properties either to draw out and do in separate logs, or to make it compact into a single log. Okay, so now let's get a little bit more challenging here. So what if let's do solving some problems. So let's talk about the different types of problems you might be faced with. So let's just say solve for x. And let's do two different types to start. What if, so part A, what if I do something like log base 2 of x plus 1 minus log base 2 of x equals 3. I guess I'm just making something up. All right, so something like this. So you've got, the left side has some logs. Luckily, they're of the same base. And the right side, you have a number. So in order to get x out of the log, eventually I'm going to have to change this to exponential here. But before doing that, I'm going to use the properties of logs to write this in terms of a single log. And subtraction goes to division. So I'm going to have x plus 1 over x equals 3. Now it's in this nice single log form. Change it to exponential. 2 to the 3rd, or 8, equals my answer. What's inside the log? So 8x equals x plus 1. 7x equals 1. X equals 1/7. And one thing I want to caution you about is when you're solving for a variable inside a log, you have to go back to the original problem and make sure you're not taking a log of 0 or a negative. And so looking back at this original problem, if I were to plug in 1/7 for x, I'm not taking log of 0 or a negative, so I'm good. Okay, so that's one type you can have. Something similar would be, what about if I said something like this? Log base 2 of 3 plus log base 2 of x equals log base 2 of 5 plus log base 2 of x minus 2. I've got logs everywhere. What do I do here? Well, kind of same idea. I'm going to make, the only thing I can really see to do is on the left side, that's separate logs. Let's make it into a single log. So addition goes to multiplication. And on the right side, same deal, log base 2 of, I'll have 5x minus 10, again, addition going to multiplication. And the only way this is true is if the insides are equal. So I have 3x equals 5x minus 10, or 2x is 10, x is 5. And again, you just want to go and double check, since you're solving for a variable that's inside the log, making sure you're never taking a log of 0 or negative. And I'm not in this case, so I'm okay. So those are two different types where you're solving for a variable inside a log. Let's get it again, even a little bit more challenging. Okay, what if I were to say, let log base 2 of m, I'm trying to think, let log base 2 of m, actually, no, scratch that, let me change that. Let me rearrange it. Let me say, let log of 7. Yeah. Do I want to do 7? Sure. Sorry, I'm trying to think about this on the fly. Let log of 7 equal x. Find log of, let's see, log 490 in terms of x. Okay, so the goal is to make it so that I can have no more log and use the property of log so that I can also have a log 7 I could substitute in x4, or just be able to evaluate the log. So if I think about 490, two things I want to think about. I obviously want to think about log base 10 of 7. Remember, if there's no base, it means common log. So log base 10 of 7. But remember what we also know. We also know log base 10 of powers of 10, like log base 10 of 10, log base 10 of 100. So how can I use the properties of logs to break up 490? So to think about that, well, 49 is 7 squared. And so 490, 7 squared is 49, so 7 squared times 10. Well, that actually is pretty helpful, because this is equal to log 7 squared plus log 10. Or in other words, it's equal to 2 log 7 plus log 10. We know log 7 is x, so it's 2x, and we know log 10 is 1. So that's another type of problem you could have, where you have to think about, how can I break up 490 into things that, what does it multiply or divide to, and will that help me? Do I know enough information to then be able to split it up and substitute in the known quantities or variables?